They said the word normal distribution. That means data makes a bell-shaped curve. So if you were to make a histogram, it would look something like this. The mean is 15, so that means right here in the center it's 15. And the standard deviation is 3. So we can use the empirical rule to say something about how many numbers are between these two numbers. Look, I added a standard deviation and I subtracted a standard deviation from the mean. The empirical rule, which is sometimes called the 68, 95, 99.7 rule, is a way of quickly telling where 68% of the data is, where 95% is, and where 99.7 is. 68% of the data is between these two numbers. What is the probability that a randomly selected game the player scored greater than 24 points? So 24 is somewhere over here. Let's keep counting out. Let's do another standard deviation down. So this would be 9 and this would be 21. So 95% of the data is between 9 and 21. Go one more standard deviation and I think we'll hit 24 over here. So 99.7% of the data is between 6 and 24. That's what the 68, 95, 99.7 rule means. That's what the empirical rule tells us. So they said, what is the probability that randomly selected game the player scores greater than 24 points? So this is 24 right here. This is the greater than direction. Okay, so we just want to know the area in this one tail. So we can use this fact that 99.7% of the data is in between these two numbers, 6 and 24. And then that should leave a certain percentage for each tail. You've got 100% total under the curve. So if you take out that center piece, the 99.7, you got 0.3% to split up between these two. Okay, so you got 0.3% over here, 0.15% over here, because you got to cut it in half, and 0.15% over here. If 99.7% is in the center, then you've got 0.3% in the tails. So cut that in half to split it evenly amongst the tails. And so now we've got the area we were looking for. It's 0.15% of the data is greater than 24. Same type of thing for this question. I think they said, yeah, it's normally distributed. The mean is 72. The standard deviation is 15. So let's start counting since this is an empirical rule question. We'll take 72 and subtract 15 from it. So that's 57. And 72 plus 15 is 87. So we're looking to hit 72. Oh wait, sorry. We're looking to hit 87 inches. Oh, that's right here. We're almost done. What is the probability that in a randomly selected year the snowfall was less than 87 inches? So we want all of this area. Okay. And the empirical rule tells us within one standard deviation we got 68% of the data. And it's asking for a probability, so watch out. That's different than the last question. So 0.68 is the probability of being between these two. So we know what the middle chunk is right here. We just need to know what this tail is, and we can use the same trick we used in the previous question. 100% is the total area under the curve. If you take out the 68%, then you have 32% left to split up evenly in those two curves. So that means this is 16% and this is 16%. Okay, so if you want to know this shaded area, which is the area being less than 87, then it's going to be the middle chunk right here, the 68%, plus this 16% for this tail over here. Okay, so this isn't a probability though. That's 70, 84. It's 84%. So if they want a probability, it's 0.84, decimal form of the percentage.